Let's take a look at a difference of squares. So in the last video, we talked about perfect square trinomials and a sum of squares. We discovered that a sum of squares is not factorable. There's no way that we can break that x squared plus 4 into two factors that would multiply together and give us x squared plus 4. So for difference of squares, though, if we just change that middle sign to a subtraction, we are able to factor it. Before I show you how to factor it, let's take a look at multiplying. Suppose I had x plus 2 times x minus 2, and I needed to multiply it out. I like multiplying using the box method, so I'm going to set up my box, x plus 2 and x minus 2. And then we multiply x times x times 2, x times negative 2, and negative 2 times positive 2. Writing these factors out, x squared plus 2x minus 2x minus 4. Check out what happens with those middle terms. They cancel each other out. And in the cancellation, we're left with x squared minus 4. So this would mean that x squared minus 4 has the factors x plus 2, x minus 2. How are we going to be able to factor these difference of squares just by looking at them? Well, we're going to notice a pattern. Notice with x squared minus 4, the first term is a perfect square on x. The second term is a perfect square, in this case for 2. And we have that difference in the middle. Remember, these are called a difference of squares. So we have a difference of squares. Once we determine what is being squared, then our two factors will always be a sum and a difference. The first factor being squared goes in the first slot, and the second factor being squared goes in the second slot. And that's it, we're factored. X plus 2 and x minus 2 actually have a special relationship because they are the same terms, just with a difference in the middle sign. Just in the difference of the middle sign. These are called conjugates. So conjugates in mathematics have the same terms. They just differ by one sign. Not both signs, just one sign. And by both signs, I mean the invisible sign that's sitting out here in front of the x in the beginning. So a difference of squares factors into a product of conjugates. Let's take a look how to do one problem together. 36 minus a squared. The first step is to check, is this a difference of squares? Do we have a difference? Yes. And do we have two perfect squares? Yes. 36 is 6 squared, and a squared is a squared. So we call this little guy a skeleton. It helps us with setting up the problem. Once we have our skeleton, then we can create our skeleton of the factors. And 6 in the first parentheses means we put 6 in the first slot for both factors. And a in the second parentheses in our original skeleton means we put A in the second spot in both factors. And those are our factors. So 36 minus A squared equals 6 plus A, 6 minus A. We can do the same thing with these problems down here, and I'll take a look at number 8 with you, and I'll leave the other ones for you to do. One thing to notice though, there are some sum of squares sprinkled in, so make sure you're really paying attention to those signs as you move through. Take a look at the first one, number 8, factor w to the 4th minus 49v squared. Looking at the first term, w to the 4th, we could write that as w squared, because when we square a square, we're actually raising it to the 4th power. 49 is 7 squared. Notice I have a v squared in there, so I'm going to put the v also in that skeleton parentheses. And then just like we did before, in the first spot, we're going to put w squared. And in the second spot, we're going to put 7v. And those are our factors. W to the 4th minus 49v squared factors into w squared plus 7v times w squared minus 7v. Same terms, just a different sign. Try the other ones for practice. If you want to, you can pause the video here and practice these before going on to sums and differences of cubes. Let's take a look at sum and difference of cubes. These are another set of special products that we'll be looking at that have a particular pattern for factoring. And I will give you a few mnemonics to help you remember what that pattern is. Taking a look at the first example, factor x cubed minus 8. First thing to notice, x cubed minus 8. This is a 2-term polynomial. I don't have any greatest common factors to pull out, but notice that x is being cubed and 8 is a perfect cube. 8 is 2 times 2 times 2, 2 to the 3rd. So I can, similarly to factoring the difference of squares, we can create a skeleton for a sum or difference of cubes. So the skeleton, I'm going to match the sign in our original problem with the skeleton that I need. Now, if you were doing this on your own paper, you wouldn't have both skeletons written out. You would only write the skeleton that you needed. But the first one there being a sum, it's just to remind you that this process is going to work whether the original problem is a sum or a difference. The factoring is very similar. So we fill in the skeleton, the subtraction skeleton, x to the 3rd minus 2 to the 3rd, and then the factors will follow a particular pattern as well. In these parentheses here, I'm going to write the associated pattern with the terms, and then we'll talk about what signs go in. So I'm referring to these patterns down here. The difference of cubes and the sum of cubes, I just want to point out, notice that the A and the B in both patterns are identical. A, B, A squared, AB, B squared. The only thing different between them are the first and the second signs. The third sign is positive. And so we end up with the same sign as what's given in the problem, opposite of what's given in the problem, and then the third sign is always positive. And the way to remember that is SOAP. Same, opposite, always positive. So I'm going to write down my signs based on the sign up here, it's negative, same, opposite, always positive. Then I can write in the bases based on this pattern. So A is going to be my first base. B is my second. Okay, so A, B, A squared, AB. Instead of x times 2, I'm going to write that as 2 times x. And then B squared, 2 squared, which is 4. Go ahead and multiply out any numerical squares in our factors. So x cubed minus 8, factoring it out, is x minus 2, x squared plus 2x plus 4. The trinomial at the end, most of the time, is not factorable. So we would want to try to factor it again, but two numbers that multiply to be 4 and add to be 2, they don't exist. So we won't get anything else from that. And there we have our factors. Let's try one more together. I'm going to do number 15 and let you do 14 and 16 on your own. I will provide the answers inside the OneNote, so you can always go over into the OneNote and check your work. Make sure that you did it correctly, and if you didn't, try to readjust. If you didn't do it correctly, see if you can find your mistake. So on number 15, the first step is to determine what's being cubed. And we already did an 8 problem, so I know 8 is 2 cubed. A to the 9th is actually a to the 3rd cubed. And if you remember from previous classes, if we have exponents raised to exponents, we would multiply them. So 3 times 3 gives us 9, which is how we know this is going to work. One of the properties of exponents that we can take advantage of. So in this case, for the b to the 6th, well, 6 divided by 3 is 2. So I want a b squared inside that parentheses. We can write out our factor skeletons. Same sign, opposite sign, always positive. And then the pattern a, b, a squared, ab, b squared. Whatever's inside the parentheses is a. So this is my a, this is my b. So a cubed plus 2b squared. A squared, I have a to the 6th. B squared is 4b to the 4th. And in the middle, multiplying them together, 2a cubed b squared. Now remember, this is a pattern that you just have to memorize. The good news to the pattern is whether it's a sum or a difference, that letter pattern, a, b, a squared, a, b, b squared, is the same. Sum or difference, that's the same. In the middle, the signs, same, opposite, always positive. Okay? It just takes practice with the sum and difference of cubes. Practice and a little bit of memorization. And that concludes our work on special products. We have 4 that we can factor, a perfect square trinomial, 3 terms, that we can use the AC method on. A difference of squares that we could also use the AC method on with b being 0, but oftentimes it's easier to recognize the difference of squares and that we can just factor it. with those conjugate pairs. The third and the fourth that are factorable are the sum and difference of cubes, and we have a pattern for that we have to memorize. And then the last type of polynomial that we discussed was the sum of squares, and I leave that to the end because it is not factorable. We cannot split x squared plus 4 into 2 factors and be able to recover the original polynomial. So continue to practice, and we'll see you again soon.